Okay, so we implied a few minutes ago what the M plus peak was, or we said it, and we implied what it means. But let's look at this a little more carefully. Let's analyze the M plus peak, or the molecular ion peak. So the mass spec for benzene is shown here. The molecular mass of benzene, right, it's C6H6. So it's 12 times 6 plus 1 times 6. This is the molar mass of benzene, right? I'm rounding, of course, because this thing measures things very precisely. So 8, what's 6 times 12? 72 plus 6 is equal to 78. And look at that right there. Boom. Okay? So that, the base peak, is the molecular ion peak, because with benzene, this fragment does not, or rather this molecular ion does not easily fragment. That's not always the case. In pentane, it looks like it does easily fragment, right? Because pentane, C5H12, 5 times 12 plus 12 times 1 equals 60, plus 12 is equal to 72. So the molecular ion peak is right here. Boom, right? But it looks like the most common peak is here. So for pentane, the parent ion fragments very easily. And it looks like the most common fragment we're going to get as we break this thing up is down here at, looks like it's 43. All right, so the M plus peak is still here, right? That's still the M plus peak, but it's not the molecular, it's not the most common fragment. But let's look at some other things, and then we'll move on to the next peak. So the first step in analyzing a mass spec is to identify the M plus peak, right? The M plus peak is the charge. It's the mass per charge. I'm having trouble talking this morning. It's the mass per charge of the parent ion, or the molar mass of the compound. This is what we've said several times now, and hopefully that's something that you'll really get a good grasp on. So an odd massed M plus molecular ion peak generally means that there's an odd number of nitrogen atoms in the compound. All right? An even number means that there's either no nitrogens or there's an even number of nitrogens. It's funny that that's the case, but that's just to prove that to yourself why that is. Let's look at the molar mass of this. This is 17, right? And water is 18, right? And methane is 16. And most of the things we're dealing with in organic chemistry are carbons, nitrogens, hydrogens, and oxygens, right? So that's why we can make this general statement, and it's super, super useful. An odd number means we typically have an odd number of nitrogen atoms in the molecule. An even number means we don't, okay? And so some masses here are calculated to help you think through that.